So I did my undergrad in computer science, so I've been a software guy for kind of a long time. I was a web developer in the New York tech startup world for a while. I worked at a company called Dropio, which was a file sharing service, and then a startup incubator called Q Labs. I left Q Labs to go to the Media Lab at MIT, where I just graduated in June. And then ever since then, I've been working at Dragon as an engineer, so maybe about 3 months or so now. So what is Dragon? We help hardware entrepreneurs like you guys succeed, basically. That's our broad mission. So we can help you do everything from plan, to fund, to make, and then eventually sell your product. So we were founded back in 2009 by Scott, who's our CEO. He was a former iRobot engineer and one of the guys responsible for basically producing 40,000 Roombas every week over in the Far East. So we've got about 10 people in Boston, another 10 or so in Shenzhen, Shanghai, and Hong Kong. And the core of what we do is we help entrepreneurs find factories to work with, and then we also help you through the project management portion, that 6 to 7 months while your product is being produced in the factory. We also have the only hardware-only crowdfunding website out there. We've got a lot of great projects on there, soon to be another one, Fiesta 5. A bunch of them have already been successfully funded. We had a project called Tessel, which raised about $200,000 among another cool one. Oh, yeah, back there. Dash Robot, Hammerhead is this cool bike navigation tool. So anyway, I recommend checking it out, Dragon Innovation. But anyway, back to the talk. So just earlier this month, I went on an epic factory tour throughout China, along with our VP of Manufacturing, Adam Kraft. And together with our Far East team, we visited half a dozen factories in Shenzhen, Shanghai, and a city called Shaoguan. And being a computer science guy, this was all very new to me. So it was extremely exciting, and I very carefully documented everything I did. So I took a lot of pictures and videos, and I thought there was a lot of interesting stuff that I learned, a lot of misconceptions I had about how things worked, especially over in Asia, and how contract manufacturing works in general. So I thought I'd share it because I thought it was kind of just practical advice. Might be interesting to you. But since the trip, I've really come to like the term contract manufacturer over factory, because factory implies that they're just making stuff for you, whereas these contract manufacturers are really doing everything from beginning to end. And that was one of the biggest things that I was struck by when I went there. They really handle everything. And you'll generally see that oftentimes there are enormous complexes, not just one building, like buildings that extend far into the horizon. They have a ton of internal capabilities. They have dorms on the campus oftentimes for their workers to stay at, so that they're always nearby. It's a college campus basically. And so they really handle everything from designing to making to testing to packaging. They'll have on-site staff that are mechanical engineers, electrical engineers, industrial designers, user experience designers, even programmers to build apps and things for you. So one of the misconceptions I had was that you had to go to them with a fully complete prototype with your design files ready, all your engineering specs laid out, but it's really not the case. They have whole design teams that can do this for you. You know, you pay them enough money, you come to them with an idea, and they'll design it, they'll build it for you. Making, I was also under the impression that you had to often go to many different places to get your product made and kind of coordinate between all of them. If you needed an injection molded part, you have to find an injection molding facility. If you need your circuit board printed, you need to go find a fab house for that. But these contract manufacturers, again, handle all of that in kind of one sort of black box solution. And even if they don't have the in-house capabilities to do that particular thing that you need for your product, because they don't always have everything, they'll often have partners that they'll work with. And so you as an entrepreneur don't have to figure out who is good or where. They'll have people they like and they've worked with, and they'll just get it done for you. They also have really extensive testing infrastructures often. You know, hardware products really need to be often certified for safety, fire, wireless regulations, all sorts of things like that. And so it's normally, or at least I thought it was very a lengthy process. You have to go to your factory, build your product, go to the government, get the government to certify your product. If it fails, go back to the factory and revise and iterate. But the factory will be testing constantly along the way in-house to make sure that when you actually do go to the government or whatever regulatory agency it is to get certified, that you will pass, because they'll have the same kinds of tests in-house, packaging facilities as well. And again, if they don't have the infrastructure to do it in-house, they'll have a partner nearby who'll be able to do it for you. Yeah?
So when end customer getting that prepackaged item, or is it another step?
Usually what happens is when you're done interacting with the factory, you'll have a big box on a loading dock ready to ship out. And that's the point when the factory is done with you. And then you have to coordinate the logistics of shipping it back to your warehouse and then finding retail distribution or whatever. Also, I was, again, under another misconception that all of these factories, these contract manufacturers, are interchangeable in who they are and when you work with them. You know, they're just this solution that you give them your engineering specs, whatever product it is you're making, and they'll just make it for you. They'll just build 100,000 of them for you. But kind of like every company, they all have their own sweet spots, and they all have their own focus areas. So one that we saw, for example, really focuses on watches. They do things for Nike and Reebok and other sorts of watchmakers. This one focused on home health technologies like thermometers. This one only did toys. In fact, this was awesome because when I went to their showroom, I saw like every childhood toy that I ever had, which was really fascinating. So my advice, my overarching advice to you guys when you're looking for a factory to produce your product is oftentimes just start by thinking about the category of what the factory focuses on and how it relates to the category of the product that you're trying to make. It's a good way to start narrowing down the factory selection process. And then once you have a handful of them that are good at making what you're trying to make, the next step is you send them a request for quote, which kind of lists all of your engineering specs and other things that you might need. They'll send you back a quote. Then you should actually go and meet and discuss the project with them in person, and then eventually you choose. And so I thought that meeting process was also pretty interesting, having done it again and again and again. And a lot of these things are irrelevant, but I thought it was kind of interesting, so I thought I'd share the experience with you. So you go, and they have these, usually these large lobbies where you meet and greet. They take you into a conference room. And this is totally irrelevant, but I thought this was really, really interesting. They always give you bottled water. Like, you could start to identify which factory you're at by the brand of bottled water that they give you as a present. And so I just had bags full of bottled water that I just couldn't drink fast enough, but they kind of want you to take it as a gift. I don't know why. But so if you've ever done business in China, there's also this custom of handing things off and receiving things with two hands, which I found pretty interesting as well. Whenever you give a business card, you have to hold it, or you should respectfully hold it with two hands, and then when they give you one, take it with two hands as well. And so when you start meeting all of these salespeople and the factory owners, there's probably 6 or 7 people that come into the room. So you kind of do this little dance of giving a business card, getting one, giving one, getting one, giving one, getting one, and then you lay them all out in front of you. Everyone from the factory's over on this side, you're over on this side, kind of lay it out so that it all matches up with who you're looking at, and just keep it right in front of you. I don't know why I thought I'd mention that. I just thought it was interesting because it's just how it went at every factory. But the point of meeting with them at first is they'll always give you a factory overview of their organization, tell you about their corporate values, about what they focus on, what their strengths are, what their in-house capabilities are, maybe some famous products that they've worked on before to impress you and wow you of their capabilities. Usually just a quick PowerPoint presentation. But then the coolest part, you ask to see their facility. And it's probably a very good idea to ask them to see the facility before you want to decide if you want to work with them or not. So this was my favorite part, and I'm going to talk to you a little bit about how my experience going on the tours, because I was fascinated by the manufacturing processes, but some things that are interesting to keep in mind, and these are from a lecture that Scott had given back at Olin. It's just things to keep in mind as you're touring around the factory. Do you like the team? Are they experienced and friendly? Do they make similar products? Again, back to the category that they work with. Do they have the right manufacturing capabilities? And again, like I mentioned, they probably won't have 100% of everything you need in-house. If they do, great, but even if they don't, they'll have partners to work with, so it's not that strict that they have exactly everything you need. Does your intended volume match their volume capabilities? So one thing I noticed, I asked them a lot as we were touring around their assembly lines especially was, if we're making 5,000 units with you this month and we suddenly want to scale up to 40,000 units next month, how quickly can you spin up another assembly line? How quickly can you, spin up the tooling for that new line? Some people will say, oh, we can do it tomorrow for you. Other people might say it'll take a week or two. So you have to think about how much time that'll take. Are they financially stable, obviously? Do they have enough working capital? to get going because you often don't give them 100% of the payment. So they're going to need to have some capital of their own to get going until you pay them the rest. Do they have ties to the central government if in China? Do they have favorable payment terms? Are they transparent in their costing? This one's interesting. Do they take IP seriously? So as you're touring around, you kind of want to notice, did they show you something they probably should have shown you? Maybe with a product that is currently being produced and is not yet on the market, and they just wanted to impress you with their capabilities. But they, there's a lot of IP behind those products, obviously, and maybe the company wouldn't have wanted them to show it to you. So you can assume, okay, if they're doing that with another product, they might do it with yours. And you probably won't want that. So that's something to be aware of. Are they ethical in their treatment of their workers and otherwise? We never work with factories that treat their workers poorly, and you definitely shouldn't either. But there's definitely variations in like safety and just how good of a work environment it is. Like some assembly lines we saw, they were all wearing clean suits and had really good solder fume extractors everywhere. And some did not have solder fume extractors at all, and they were just kind of breathing in the smoke, which is not like a terrible, terrible thing, but it's not great for you either. So also something to be aware of. Do you have access to upper management, and are they excited about working on your product? Because it's not just about you selling, it's not just about you picking a factory, it's also about you selling yourself to the factory, because you want them to be excited about your product. If they are excited about your product, if they think it's going to be the next big thing, they'll devote more resources to you, they'll treat you better. So you kind of want to show them that your thing is the next big thing.
Could you speak a little bit more about the ties to the central government, how that rolled out, please?
Scott, do you have any thoughts on that?
Sure. Yeah, so what you're going to do is eventually build a lot of product, and you have to build it from China, outside of China. So everything has to be ethical and moral and above ground, otherwise you'll create a whole host of problems. But having a company that is on good terms with the central government, maybe they sit at one of the councils or things like that, ensures that your products aren't going to be hung up sitting in customs. Because one challenge is you ship it out and then a low-level shipping authority in China Customs looks at it and for whatever reason doesn't allow it to get through. And your whole business depends on getting this stuff. And there's some guy you've never met before that you're never going to contact who's holding everything up. So by having the factory boss connected in a reasonable way just ensures things go smoothly.
And does the boss take care of all that? Because some countries you need
in general, if you get stuck, you always want to be able to pick up the phone and talk to the boss. And that's why the access to the top level management is so important. And what we find for a lot of our clients is they're smaller clients to start off, and then hopefully they grow to be the next iRobot or GoPro or Cowboy or MakerBot or whoever. But if you can't access the boss, then you're never going to get ahead of the world. So, but usually a lot of it's reputation, so they may know, oh, I'm working with King at. Ray is well connected, that we're not going to hold up to things. So it's more of that, whereas if you work with a small factory that's not well established, then chances are more likely to hit it.
Scott, when you say talk to the boss, how much of a barrier is the language?
Most of it, so there's different types of factories. There's US owned, Hong Kong owned, Taiwanese owned, local Chinese owned, and then everything else. For everyone except local Chinese owned, they should speak English. And they all have their different places. Like if you work in a US owned factory, it's going to be very expensive, but the resources are going to be amazing. So they have DJs, pool, gas systems, injection molding, like to build anything. But you can pay through the nose for it. Whereas if you can work with a local Chinese factory, you'll still get a great product, but they're not going to have all the services. You have to speak Chinese, or industry is probably Mandarin. Most of the factories we work with are Hong Kong owned, Taiwanese owned, or local Chinese owned. So for 2/3 of them, they'll speak English.
Yeah. Could you talk more about asking about like are they financially stable and do they have enough working capital to get going? How do you get at those questions in a conversation?
That's a good question. Again, I guess I didn't ask those questions while we were there. Scott, do you have any experience on that?
Yeah, so if they're publicly traded, then that's a good way you can just look at their books. There's both good and bad things about being public. They'll tend to manage the quarters a little bit more, whereas if they're private, they don't have to do that. But you can also ask them, are you carrying any? Usually they're pretty transparent. Like, are you carrying any debt? What's your working capital, things like that. It also was a little bit more of a problem earlier. So in, I think it was '07, we had a lead problem on some of the toys, and that with the bad economy decimated a lot of LCMs. But in the old days, you used to be able to get net 30 payment days, which means I don't need to pay you until 30 days after I get my product. And chances are I might have sold some of it, so I have some money coming in. Right now, everybody's super conservative because the economy was in a rough spot, and a lot of them got burned. They're sitting on a lot of inventory, so they often now will require 70% of the cash up front when you order the components. So the risk is a lot less, and therefore they need less working capital. But it's always something you want to ask.
Cool. All right. So anyway, back to the fact pictures, videos, and a lot of these had the same. They had a lot of the same in-house capabilities, and so these are sort of the processes that I'm highlighting. And yeah, I was just hoping to sort of explain a lot of the different processes, how they work. I think it's really important as a hardware entrepreneur, as a designer, to know about how these things get made in scale, because when you're designing for it and prototyping it, you often don't think about those things, and then it kind of is just a pain point later to redesign it for manufacturability. And so it's interesting just to keep these things in mind. So anyway, all of these factories, contract manufacturers, had SMT lines, meaning the circuit board production area. And so when you go there, you put on these white clean suits, you put on plastic boots. Oftentimes you have to go through this cool little air filtration thing where you stand inside this chamber and then air blows on you and you have to spin around and it gets all the dust off of you. And so this is generally what a SMT line looks like. It's kind of a big chain of circuit board production machines, basically. Or I should say that usually they'll outsource the production of the actual raw circuit board to some other facility. They'll get it printed somewhere else, ship that in-house, and then it's about soldering and putting the components on in-house. So a common way to get solder onto the board is this solder paste masking machine. There's this, I presume, laser cut or somehow CNC mask over here, and then a circuit board goes up underneath, and the holes are exactly where the pads on the circuit board should be, and then a squeegee sort of just wipes some solder paste over. So it's a really efficient way of getting solder paste exactly where you need on the circuit board. These are possibly the coolest things I've ever seen. Pick and place machines. These robotic arms picking up surface mount components at a sort of blinding speed, getting it optically checked over here for like alignment, and then it's placing it on the boards themselves over there. There's all sorts of variations on these pick and place machines. This is like crazy, like Gatling gun style, like 9-arm pick and place machine that's just like jamming the components in there. Thought that was pretty awesome. And one of the things we would often ask, because all these machines are different, is what's the smallest component your machines can put on the boards? Because sometimes it's 04, 02, which are pretty small, but there's also smaller ones that are 01 something something, maybe 01, 06, I'm not sure. And so sometimes people can do those, but they can't do others. And so it's interesting to just ask them about the capabilities of their machines. Sometimes you'll have a board with through-hole components on it. It's not very common nowadays, but a lot of older boards did have a combination of surface mount and through-hole components on it, and so they'll often have these wave soldering machines, which creates this, you can't really see it, I didn't take a great video, but there's this standing wave of solder here. It's just basically a pool of melted solder, and then a conveyor belt is taking your circuit board over the pool, and the leads coming down from the through-hole components soak up the solder, and it solders in. So you also have this mask on the bottom of your board, so that it only picks up the solder in the right. Takes it through a reflow oven, which solidifies the solder, secures the components to the board. This was really interesting. I had never heard of this before, but it was really, really common between all of the factories. Some components are so small that you can't solder them to the board the normal way, like I just showed you with solder paste and putting it through a reflow oven. So they have these wire bonding machines which are soldering microscopic wires from the chip down to the board. It kind of looks like a sewing machine when it's going up and down. And then they all have these custom epoxy coating robotic arms to protect this really fragile piece on the circuit board. So they're just kind of putting down some black epoxy.
So it's the finished board is the one with those little rounded tops.
Yeah. You've probably seen them before, right? Yeah, those were probably wire bonded. They also have bulk programming capabilities oftentimes. So you have like a kind of a rack of 12 or 15 of your chips. You put it into this machine. They just easily download your code. It tells them if each one actually successfully uploaded or not. They can record the serial numbers of which ones actually got successfully uploaded. Again, a really efficient way of doing it. And oftentimes there's some kind of inspection process as well for your circuit board. Sometimes they'll have manual inspection where people are just kind of spot checking various joints. Some contract manufacturers will have an X-ray inspection machine, although as we heard from a lot of them, they were saying it's a pain in the ass to set up, so they often don't use the X-ray inspection machine unless you have a really super complicated 4-layer board or something like that. But they almost all have this, which is an optical inspection, automatic optical inspection, or AOI as they called it. It took me a while to figure out that acronym. And you put this board into this machine, and you've got a microscope that's checking all of the solder joints optically. And again, one of the things we would ask is, do you do 100% inspection of your boards? Because some people will say, oh, we only spot check. Some people will say we do like 50% checks. Other people say, oh no, of course we do 100% inspection of your boards.
To what extent do you recommend or not recommend having like self-test features?
Having what?
Self-test features like in an intelligent device.
You mean software-wise, or?
Yeah, so that the board is testing itself rather than using an external.
I guess it's always a good idea. I don't know.
This is kind of a different process. This is like literally physical checking.
Yeah, it's physically checking the joints to make sure that everything's connected the way it should be.
Yeah, so this is done so that you can fine-tune your production. Like if there's a problem in taking place, that's where you find it out.
Mm-hmm. Yep.
If there's a problem with your reflow and temperature profile or waste,
exactly. They also often later times will have the functional testing, like on the assembly line when they're actually putting the circuit board into whatever enclosure it is. We often saw that they would hook it up to a computer, plug in a USB port, connect it via Bluetooth, run a couple tests, make sure it passes, and then set it on. They're constantly testing along the way to make sure that things are passing. Yeah.
So who's developing all these tests, especially the vision test?
The vision testing they set up. You probably give them your Gerber files of some kind, and then they somehow translate that. I don't know how it works, but they translate that into whatever the machine does. So you have to give them that, but then they'll check it. And then again, for the functional testing, you probably are designing that as the entrepreneur.
Is it common in these companies to find like flex board printing?
Yeah, they often have that actually. The contract manufacturers themselves are not often the ones that are printing the board itself, so they can outsource that and get a flex board or a hard board printed. We saw at one factory. It was really cool. They actually have a new mix of flex and like solid boards, where like there's a flexible part attached directly to a solid part. And there's all sorts of cool things they can do. Yeah.
So does that mean that they don't validate the design of the circuit board?
Will they validate the design of the circuit board? I guess they don't do that. Scott, do you know?
In general, they wouldn't, on these tests, they wouldn't validate your design, but they would do the AOI, they'd probably do an ICP or the circuit test with like the nails. Functionally, testing is always a good idea. So I always like to use Windows as an example, because they're not iRobot's not a client, but we know a lot about it. So what you want to do is that is a 5-degree of freedom robot with all these different modules, and it would have been insanely hard to put them all together and hope it worked at the end, like you have zero yield. So what we would do is build a module and test that, and you can use the board to test the module. So we had this thing called the built-in test for the bit, which had, I think, 21 different stages, something like that. And we would wiggle the actuators and listen to the sensors and flash the lights. And you could actually, like, suppose one test was checking the wheel module motor control. Let's call it step 13. They would actually take a Roomba board, set it to step 13, put an enclosure behind it, or around it, and then plug all the modules in and measure the current to make sure that's right. So it's sort of like this weird recursive thing that uses a robot to build the robots. But things like your circuit design or tolerance stacked up is always a big deal. Especially when you go within the components or reel to reel, like each reel holds about 5,000 units. So if you only build 5,000 units, you're probably fine, but if you build more than that, the reel to reel variation will be there. And they likely won't do that. Those are things that you have to do. But they'll do all the IC stuff, doing all the AOI programming.
Cool. So another section of these contract manufacturers that obviously they all had were assembly lines, probably the most famous part of the factories. There was a ton of super interesting things, but first, just in case you're not too familiar with how it works, there's a hugely long table, people sitting on either side, some kind of conveyor belt or platforms moving from top to bottom. And usually you'll start with some raw materials at one end. It'll start moving down the conveyor belt. People will take something off, do some operation to it, like screw something in or attach something or add the circuit board or glue something to something else, put it back on the conveyor belt, and then someone else will take it off down the line, do their operation, et cetera, until at the very end you have a just fully completed product. It's really fascinating actually to see how it transforms from beginning to end, because it goes from nothing to like production ready product very, very quickly. And we also notice, as I mentioned before, some assembly lines will be, I guess, more well cared for than others. This one, for example, everyone was required to wear these white suits with hoodies with masks on, and usually you only need something that's like that protective if you're making an FDA approved product or something. This factory wasn't, they were just being cautious. And you can see they all have their own solder fume extractors as well, so this was kind of one of the higher end ones. It's just a quick video showing you that there's this conveyor belt down the middle. People are occasionally taking things off, putting things back on, doing their little operations to it. But the coolest thing I thought about assembly lines is this thing called fixtures. And you often hear this term a lot. I've heard it a lot in the past couple years, even before being at Dragon, and I never really understood what it meant. And people always talk about it as this thing that is actually a significant portion of the bill when you pay the factory. You definitely have to think about this. And I didn't know what it was. And going there, I now learned. And there's a ton of engineering that goes into making an assembly line really efficient and making you able to produce the high volumes that you're able to produce. And it's all about engineering these little fixtures and rigs and gadgets to make the assembly time shorter and make it a lot easier to put something in something else or screw something into something else. So I thought this was fascinating. You can't really see it, but this little device is ingenious. It's just a block of wood with holes drilled into it that are the exact size of the screws that this guy was using to drill something in. You dump a lot of screws in, you shake it, all the screws fall face down into the holes, so they're all very well aligned. He could just take his drill, quickly grab one, put it in, grab one, put it in, so he doesn't have to be aligning and reorienting these screws constantly. The alternative is you pick one out of a bag, fidget with it, get it in the right place, put it in the thing, and then screw it in. Here, he's just like zipping away. And there's all sorts of custom-built gadgets and rigs and things that exactly fit the product so that you can easily snap something into something else. It was really fascinating to see that. Major part of the production process is tooling and molding. Molding is probably this process you've heard a lot in terms of injection molding, die casting, things like that. And it's one of the more ways of creating the shape of a part that you're making. And tooling is the process of creating these molds for your parts. And the tooling process itself is also another one of these really expensive things that you've probably not really thought about before. It takes a lot of time and a lot of effort to do it. And they have dedicated machines to making these molds. Usually you make a mold out of this big block of steel so that it can withstand, 1 million injections of hot plastic. But cutting away at steel is really, really hard. So they have these things often called electrical discharge machines, EDM machines, which I believe I have a video here. They have some kind of like copper electrode here. This is your steel mold that you're making, and by sending a current through the copper and through the steel, it's very gradually eating away at the steel, like layer by layer by layer. It takes a really long time, but you get a very accurate, very well-made mold out of it. And there's other ways also, in addition to this, to making molds, like CNCing it with a machine, or otherwise machining it manually. But this is one of the more prominent ones that we saw that was being constantly used. And oftentimes they'll use a combination of EDM, CNCing, or some other process. So these are what some finished molds look like. They're huge blocks of steel, usually 2 halves, but sometimes they'll have 4 or 5 or 6 moving parts that all kind of snap together in some way so you can get the geometry of your part out. This was an easy bake oven mold that we saw in the toy factory. I thought that was really cool, so I took a picture of it. Oftentimes there's a lot of effort devoted to polishing the mold, the inside of the mold, to get a really smooth finish. This whole room was devoted to that. All these people had these little Dremel type devices just polishing away on the inside. So, okay, so back to molding. You've probably heard of injection molding before. In this process, you've got a big machine. You take your two steel mold halves, it smashes them together, injects some molten plastic into it. It cools really quickly. The mold halves come apart, and then you can get your piece out of it, such as that piece. And then again, they go back, they inject. This is a pretty slow one, but often they can go kind of pretty quickly to get your pieces out. Die casting is a pretty similar process to injection molding, but instead of plastic, it uses metal. And so in the die casting areas, you'll see these huge blocks of raw material, aluminum or some other kinds of metal, steel. So these are the machines here. And what this thing is a bucket which picks up the raw material, melts it down, and then delivers the raw material to the different machines. Kind of specific to die casting because the process of melting metal is a lot harder than melting plastic. Can you hear that like tune? They had this cute little tune playing whenever this thing was moving, so people would know that the thing's moving and there's hot molten steel above their head. Thought that was cute. So again, it's a very similar machine to injection molding. Two mold halves come together, molten metal is injected in, and then you get your metal part out of it. Often there's also, so you get like a ton of similar pieces right out of it. There's also usually this finishing process where they sort of tumble the metal pieces with these ceramic discs to finish the part, to smooth off any rough edges so you don't have any sharp edges, and kind of to polish it. These are toy trains that they're making. It's just kind of vibrating. It was very loud. They all had ear protection. Roto-molding is another cool molding technique. You can use this to make a lot bigger parts than injection molding or die casting can make. Usually it's used to make doll heads or legs or large things like canoes. And the process is you inject metal, like plastic goop into these whole molds. You put a little cap on them like that. And then you put them into an oven, and while it's in the oven, it's rotating at 360 degrees constantly while the plastic is baking. So the plastic is coating the inside of your mold as it's rotating around, and then gradually it hardens into this hollow mold shape that comes out. And so usually you need to use a flexible material because otherwise it's impossible to get out of your mold, which is often perfect for like baby flesh toys. The other cool feature of this is that you only have one whole mold as opposed to two mold halves. So with injection molding, you often have this feature called a parting line, which is the line on your part where the mold halves came apart. So there's a lot of like engineering that goes into hiding that parting line because it looks bad. With roto-molding, you don't really have that because it's one whole mold. Again, two mold halves, you put some kind of plastic-ish material in the middle, and then it goes into this press, which just pushes super hard on it. It melts the metal in the plastic in the process, and then out comes the shape of the piece. And this one's manual, but there's definitely automated compression molding machines that can do it much quicker, and this guy's doing it. They were making wash bands, I think, there.
So it doesn't apply heat manually, it's just, it comes from the compression molding?
No, I think heat is applied, yeah. So also they had huge infrastructures devoted to finishing off the products that they're making, like painting, decorating, other sorts of things. So there was a lot of spray painting capabilities. This guy's doing it manually, kind of grabs one, spray paints it. He's in a little ventilation room. Electroplating was possibly the coolest thing I've ever seen. There's plastic, so you'll have your plastic part, like this World Heavyweight Wrestling Championship belt. You can coat it in a conductive paint. That's why it's kind of shiny. You put it on a big roller like this, so this whole thing spins, and then each one of these racks spins in it. And in the center here, you have electrodes with a little like an aluminum solid piece of metal on each electrode. You put that whole thing into an oven, and then it's rotating everything around, heating it. You send an electrical current through these electrodes here. It vaporizes the aluminum, and also by sending the opposite charge to your parts that are coated in conductive paint, the vaporized aluminum will then stick to the part, and you get this cool, shiny metallic coating, kind of like that. Very sciencey way of painting something. Electrodeposition was a very similar process, but kind of used in a different way. This is a way of painting different parts of a given product, different colors. So what you would do is you take a part, one of the parts, you embed it into a block of wax, and then there's like a worker that has a soldering iron looking thing who's melting away parts of the wax to expose a very specific part of the part that you want to paint. And then you put it into this copper bath solution. You can see there's bags on either side here which have copper chunks on it. And then via some chemical process that I didn't really understand, the copper gets dissolved into the solution, and again by sending a charge through the solution and through the part, the copper starts to stick to the shape of the part, and you build up this metal mask in the shape of the part. And then you can use that mask later to spray paint exactly the part of the piece that you want. So this was a cool little rubber stamping machine. There's this stamp over here picking up some ink, just putting it on the part with like a label. And again, this is another cool fixture they have. It's exactly molded to fit this part, so it's always aligned properly. And then she's putting it into the oven to cure so that the ink doesn't run. Saw silk screening a few times. Again, a little jig to put the piece in. You rub some ink over a little silk screen stencil. You get the logo onto your part. This was probably the creepiest room we saw. It was a huge room devoted to just putting hair on dolls. And so this is kind of this weird sewing machine. I think you can see he hits himself with it at one point. He kind of like sticks, yeah, right there. It was really hard watching them do that. But huge rooms devoted just to doll heads, putting makeup and hair on it, just heads on sticks constantly. So they also, like I mentioned, have a lot of testing and certification infrastructure. It was actually really, really surprising to see how much testing infrastructure they had in-house for every sort of thing ever. And some contract manufacturers will have better testing than others. Like, for example, this toy factory that we went to is like really on the up and up with testing their products, because when you're selling to kids, you really need to make sure that you're not selling them anything hazardous or dangerous or it's going to have in it. And so, one recall could really shut them down completely. So they're really strict about that. We saw a lot of functional testing machines. This was a custom-built Nerf gun dart loading machine that just put darts into Nerf guns so that humans could then pick up the guns and shoot and test and make sure that they were actually working. This is a thermometer testing machine that they built. It's just water heated to a specific temperature, and they put the thermometers in to make sure that they're reading the right values. There's an RF shielding room to test radio frequency devices. There's a lot of Wi-Fi and Bluetooth testing that was going on to check for like FCC regulations, make sure that they're not emitting frequencies that they shouldn't be. Waterproof testing, just a bucket dumping water onto it, making sure if it works later. Saltwater spray testing was a very common thing. I'm not entirely sure why that was really important to everybody. Temperature and humidity testing. This was the factory making the GoPro camera. It's just a device pushing the button over and over and over again. Make sure that it's not breaking when they push it 1,000 times. This was a vibration testing machine. This platform here is vibrating really quickly, so you can't even see it, but they've got some mobile scanners that are strapped to it, and they're just testing to make sure that they're not breaking mechanically or electrically on the inside. One of the creepier rooms, they're testing color of video cameras that they're producing. I don't know why they needed this doll, but she's holding the chart that they use to test the color. They had some resolution testing. This was a factory that was making a lot of camera, like audio and video devices. And so the toy factory, as I mentioned, does a lot of laboratory testing. They had huge amounts of just like really hardcore chemistry, science kind of testing going on. Right here, they're testing for lead and other hazardous substances. You'll probably notice there's often like a label that says ROHS on a product to indicate that it doesn't have lead and other hazardous things in it. So what they're doing here is they were cutting up really small chunks of the toys that they were making, like all the different parts of it, the enclosure, the circuit board, whatever, dissolving it in various types of solutions to check if hazardous things were coming out of it. Because it's not just one thing to say, oh, we didn't use any materials that had lead in it, but now you could assume, okay, a kid breaks it, eats it, now it's dissolving in his stomach. Are bad things going to come out of that when that happens? And so they're really checking for everything. And again, as I mentioned, they'll also have packaging capabilities to print the cardboard boxes, like the instruction booklets and whatever else goes inside. And again, if they don't have the infrastructure bags in-house, some of them had it, but if they don't, they'll have a partner where they can get all that stuff made and shipped to you. You as the entrepreneur, you'll design your packaging, but they'll get it made for you. And it's like oftentimes, it won't just be like a strict cardboard box, but I've also seen things that are injection molded hard plastic cases that are used to wrap something. And so obviously if you were doing that, it wouldn't be this sort of process, but it'd be going back to the whole tooling and injection molding process that you would need to create the packaging. So it's a little more complicated to do that, but they can help you out with that too. So that is the talk, I guess. So thanks. And if you guys have any more questions, we can chat and Scott can help out. But yeah, anyone have any other questions? Yeah.
Agreement enforcement. If something goes wrong, okay, how well does the legal system work? Do you get your money back, or do you get...
When you sign a contract with them, when you're doing it, you specify every possible scenario that could go wrong, and so you assign who's responsible for what, who pays what when something is late or something is broken, or you specify. You're almost certainly going to have a lot of parts that break or that are just not working when they come off the assembly line, and so there's some amount of like scrap that's designated as saying this is an acceptable amount of broken things. So you specify all of that.
The contract's really nice, but
how well does the legal system work? How well can you defend your rights?
So there's no functioning legal system in China. That's definitely the short answer. But which actually isn't necessarily. I mean, eventually it will get there. There's no precedent, or case law to look back on. But what you want to do is really develop a close relationship with your factory and get your incentives aligned. So as Shaun mentioned initially, when you're going through the request for quote process, you want to get them excited about your project and let them know, it's the next robot or GoPro or Pebble, so that it's in their interest to ship goods. There's also a lot of reputational things. So if you're working with a US-owned, Taiwanese-owned, Hong Kong-owned factory, they're going to have a lot of other clients in there that are probably a lot bigger than you. God forbid there's ever like a reputation issue, but if that ever happened and Hasbro's a manufacturer hotel, they would shut it down. That would be the end of it. So there's a lot of motivation there. We have the MSA, or the Manufacturing Service Agreement, and the whole trick of that is anticipating what can go wrong before it goes wrong, because otherwise it's just finger pointing. And if there's nothing, like hardware is insanely hard anyhow, so being able to anticipate, like, oh, if this happens, you guys are responsible. If it's our problem. The challenge is also that there's also a lot of gray in there, that it could be a design issue, it could be a manufacturing issue. And those you just have to work through it.
Does using some of their design services help smooth that over? Or?
It does. I mean, when we look at factories, we like to have them involved in the design for manufacturing assembly for a couple reasons. One is it's often a lot more cost effective. Two, they're a lot better at it often than we are over here. And three, as you said, they get bought into it. So if they designed it, they have to be able to build it. They can't say, well, I'll just design crap. So that helps. And it gets some, they're often really, really good at what they do. So the design they come up with is going to be a lot more manufacturable. The other thing is every factory has different capabilities. So as Shaun hinted at, some have die casting, some with injection molding, and they'll tailor their design to meet whatever they have. But when you think about what can go wrong, there's a few things. Like one, you can be late, and if you're a consumer electronic product trying to hit the holiday season, that's devastating. So you want to have motivation. they ship it, but you also have to have good quality plans that they don't ship crap, they get it out there. So you have all these final inspection, like mil spec 105 A2L levels, so you can inspect and make sure that the goods are good. So there's a lot of different layers to it.
Yep.
How long does it, if you got a product, how long does it take to go through the whole process to get your first shipment?
I guess it can vary based on your product. Usually that request for quote portion where you're selecting a factory can be 1 to 2 months. And then the product, like the production phase, can be 6, 7 months to get your first shipment. So figure, what, 8 to 9 months or so is usually a good estimate.
That's the time that they do like all the fixtures and everything, and then they start production at the end of those 7 months? Or?
No, so they'll start that. No, they'll start that at the beginning. By the end of that 7 months, you'll have your product, like in packaging on the loading dock, ready to go. Yeah.
So how does this all compare to the U.S.? I mean, I've done some of this here, and a lot of this looks pretty familiar. But I mean, what are your biggest takeaways if you've done manufacturing in the U.S. comparing to China?
Sorry, I was just going to say one of the things that I noticed is just that here things are a lot more split up. You know how I mentioned at the beginning, one of the things I was impressed by was that they handle everything in-house. In the U.S., it's disjointed more. Like you will have to go to an injection molding facility to do one thing. You'll go to a fab house for your circuit board to do another thing, and then you'll have to coordinate getting all that stuff shipped between each other to get that made. Whereas there, it's just this one-stop shop. I guess that was my biggest thought. If you have anything else?
It's something we look at here at Atlanta. We always look through the lens of how do we make sure the entrepreneur succeeds as opposed to trying to shove things to the U.S. or shove them to China. But for us, it's really a volume issue. So if you're under 5,000 units, like if you're under 1,000 units, your dining room table is great. If you're 1 to 5,000, it's a little awkward volume, but the U.S. would make sense because you can just drive or fly to somebody in English and you're probably iterating pretty quickly there. The challenge is as you ramp up to a higher volume, chances are labor is more important, and especially if you're consumer electronics, so you want to get that down. It's hard to do in the U.S. unless you automate. So then if you start in the U.S. and then go to China, you throw away all that domain knowledge, you start again, and chances are when you're moving, it's when your volume is really heating up, so it's like the last time in the world you want to go pick a new factory. The tools we do in the U.S. are mud frames, some master unit dies, so it's like you just make the insert, whereas in China we have mold bases, so they're not inherent. You can't flip one for the other one easily. So it's one of these things where the decisions you make up front are going to cast a really long shadow. But if you're doing a product and said, oh, hey, Scott, we need 50,000 units, I feel good about my forecast, then that would indicate China might be a better choice. Whereas if you were to say, we need 3,000 to 5,000 units, then the U.S. just it probably makes a lot more sense.
And what about turn time? I mean, is it that bad? You're talking about 8 months or so, 7 months to go start to finish. Can I do it faster in the U.S.?
You probably could do it faster in the U.S. I mean, one is just the shipping. If you want to air ship it from China, it's expensive. And of course, it depends on the size and the weight of the thing. Two is if you're figuring, like, we firmly believe you need feet in the ground wherever you're making. China's a long way away, or in Mexico, wherever you build, so that's inefficient. The long poles in the tent are tooling, so that's, for most of what we do, it's 6 to 8 weeks for tooling. Just here's the part I want to make, and then here's the mold that will make that part. And then the lead time of your components, which are often up to 3 months, which is a pretty long time. But if you can shorten those, then you can go faster. Then the other one is compliance, so if you need UL or FCC Part 3B or whatever it is. So it kind of varies, but I usually figure like the U.S. is a little quicker, but you can't scale as much as you might want to. Although that said, one of the things we talk about in a different talk is where to build things. And the one that I always find interesting, although it makes perfect sense, is shampoo, like poop in a bottle. Like it's super high volume, you think it would be built overseas, but I almost bet a body part. I'll bet somebody else's body part. That if you look in your shower, most of them are built in the U.S. And because it's totally automated, it's a blow molding machine, which you crank up the bottles. And the problem with poop in a bottle is the stuff varies over time. So if you put it in China, it's absolutely going to drift, and you're not going to be able to do that. You're getting a little while ago. So it is very dependent on what you do.
I'll vouch for that. Actually, for the factory, Gamble factory, to the scope manufacturing, which is a giant line going across the room of scope bottles, blazing by, like 100 every minute. There's a machine that puts the little pin on top of the scope bottle and wraps it. That machine was broken that day. they have ultimate people just throwing things out of the scope bottles. But after about an hour, they all wear out. They can no longer hit the scope bottle, so they swap them out for another. Sioux City, Iowa. Correct.
And I think along those lines of it being a far way away, is especially if you're in the earlier design phase where, if you were thinking about using like their designers in-house, I would, because you haven't done the prototyping on your own, I would probably recommend maybe thinking of doing it closer to here, because then the turnaround time between prototype iterations is much quicker because you don't have the time difference, you don't have the cultural barrier, and you can probably just go drive over to the factory or the designers to go talk to them to work out an issue if you need to. So only maybe when you're in like the later stages does it make more sense also to go over there.
So what scale do you have to get where doing like custom chips themselves comes into play?
Like an ASIC or something.
Yeah.
So I haven't done a lot with ASICs, but my understanding is when we were looking at it back in the day, it was like $250,000 to $1 million. Just NRE, they're non-recurring engineering. So you'd want to have, like, amortize that into your volume and then make sure that piece price will justify what you're trying to do.
Are there any import fees or taxes involved with importing from China?
Yes, there's a harmonized tariff code, and there's this great guy, Art Samuelson at Air Tiger, who really understands this stuff. It's an art and a science to figure it out. But you obviously, for your business, want to be classified as at least tax. I'm not an expert in it by any means, but it does seem somewhat arbitrary. So given that, you want to have it work out in your favor.
Okay, so that's one part of the equation.
It is. Yeah.
Manufacturing.
Yeah, there's a few things when you look at Asia. One is it's far away, so you're going to pay more for transportation. Now, I think it used to be a 40-foot HQ can, which is 5,000 rubles, was $5,000 to bring from India to here, so $1 would be how big that is. So it's not a lot of money, but it's not free. So you've got that. You've got potentially the tariffs.
How long is it? How long is the shipping time?
It's roughly 4 weeks to go from, and then there's, due to the Patriot Act, there's like another week where it has to sit in the container yard. Whereas if you airship it, it's sort of like a week or so, but it's 10 times more expensive for a Roomba. But that the currency, so 05 the RMB floated, it used to be nicely pegged 828, but that all changed. So now it's I think 631, and there's a lot of international pressure because it's undervalued. Again, I'm no expert in this, but I know if it goes good for the U.S., it's going to be bad for manufacturing in China. So, and nobody has any control over that. It is what it is. The factory conditions, are we can go into factory conditions later, but in general, people are pretty tightly packed. This wouldn't be unreasonable for a line. And God forbid if there's SARS or H1N1 or anything, there's a really good chance, there's a non-zero chance your factory might get sick. And again, for a human standpoint, that's a terrible thing to happen. And for a business standpoint, it's devastating as well, because everything you did is now, you're not building anything. And if you miss Christmas, you just lost a lot of revenue. Whereas in the U.S., it's much less likely that's going to happen. Just it's a different setup.
Of the companies that engage with Dragon, what percentage of them end up manufacturing overseas and what percentage do domestic?
Yeah, so when we were just focusing on the Dragon service side, I'd say 95% of them manufactured in China because they're really high volume. And often to work together, that would require that they raise VC, and they'd only have done that if they had high volume. Now that we're in the crowdfunding business too, I'd say 90% of our clients are building in the US, which is great to see, and it's fun. Like, we love learning new things, so we're sort of trying to take what we learned and know from China and then help the US factories as well. So it's sort of been a switch. And when we look out there, we see a growing, like a huge demand from 1,000 units to 5,000 units, which is totally unmet right now. Like, you need a really high mix, low volume factory, and we haven't found a great one. There's a few good ones, but we're really excited to be able to help. There's some good stuff. Tony Shea's doing Vegas, which is a great manufacturing base, and then in the Brooklyn Navy Yard, the Macro C guys are thinking about building out that, and it's got a great deep water port. So it's could be pretty exciting.
Sure. How do you factor environmental responsibility and sustainability into choosing an overseas manufacturer?
That's definitely getting more and more on the radar screen. Like, it's something that comes up. More of our clients ask about that. And there are all sorts of compliance ratings you can look at. I think it's the ISO 1400 that goes into that. The best thing we always say is, like, go over wherever your factory is, US, China, Mexico, go over and look at it with your own eyes. So one of the factories we used to work at had their own sewage treatment plant. So just to put this in perspective, like, often a factory might have 12,000 workers. That's 36,000 meals a day. So they have their own kitchens, their own dorms, their own sewage treatment, their own power plants. So you can sort of look at it from that standpoint. Often in factories, you also never see a waste basket because nothing's wasted. It's all about money in a good way, so it makes it super efficient. But in terms of a lot of it is also the materials you design your product to use, and you can specify, like, I hate styrofoam, so you can say I want, pulp packaging, or I want this, or I want that, and you're in charge, so you can get.
So what about the initial selection process? How do you look up contract manufacturers and just search for that?
It's hard. One of the things we recommend is you talk to somebody who's manufactured there before, who will have a recommendation for you, or who might know some people for you to talk to. I guess it's kind of Googleable, but not readily Googleable as to what companies exist and if they're at all reputable. But yeah, talking to people is the way to do it.
Like, if I go to a factory and say, if you screw up, you're screwing with me, in my 10,000 units versus I'm working with, like, Dragon, let's say. So do they sort of go there under your auspices when your entrepreneur goes to, so that there's more bulk to it, or are they sort of on, you just lead to the right place, but they're on their own?
Yeah, we'll be the tour guide in the boat, but also paddling alongside. So they go under the Dragon umbrella. But how we're very different from it, there's not a lot of other companies in our field, but we never do the middleman model. So the middleman model would be, you come to me and say, hey Scott, I want 100,000 widgets by Thanksgiving, and I'd be like, that's awesome, they're going to cost you $5, and I'm never going to tell you what factory's building them. And that way I'm like, we're locked in, you're not going around me, and I can charge you as much as I want, and you're never going to know. We reject that because we want to drink beer, 80 years from now, and if I'm not transparent with you, A, you're never going to learn anything. You're never going to trust me, and see, we're not going to be drinking beer. So what we do is we bring you, let's say to China, we give you all the contact info of the factories, and you'll place the POs directly with the factory. So we're never getting any feedback, and we're only working for you. And you also know if we're not being useful, you've got all the contacts, so you can do your own thing. But you get the Dragon perspective, or protection in that we bring a lot of, because we never get kickbacks, it's free business development for the factories of some of the hottest hardware companies in the world that we bring to them for free, and we're always trying to find the best match. So if they, everybody has mistakes and things, and we'll work through them, but if they're malicious or screw you, I'm never going to bring another client to them, and I'm going to make sure everybody knows. So it's not in their interest. And in some factories, we have a bell curve, and many we've worked with for a long time, that if they really mess up one, that's the end of it. They won't get any more.
Yep.
What about combining operations for IP protection? I know I've heard of people doing a lot of component assembly, but basically shipping to the flash the board to put all their proprietary controls on that. Is that something you see? Or?
You mean like splitting up the production between different contract manufacturers?
Between China and the US.
Oh, I guess you could do that.
But it was primarily for IP concerns.
Yeah.
You actually do your...
Right. No, I mean, you hear about that kind of thing all the time with the CIA building stuff, right? They'll split every single component up into a different factory so that nobody knows what's going on. So but we don't often recommend that. We tell our clients a lot to focus on protecting their software as opposed to the hardware. And there's really,
that's what I'm saying.
Yeah.
The examples I have are they've done the actual flashing of the microcontrollers or ICs here in the United States, so that all that proprietary
exactly
here. So you do see that?
You can do that, yeah.
Okay.
Totally.
We also see, what we used to do is you can consign a component. So you always want to pick a CM that you trust.
Right.
And you want to know them well, because if you have a bad CM, it's going to be a whole painful journey. But the thing you may want to protect against is a ghost shift. So again, if you have a good factory, it's not going to happen, but trust but verify. So the go shift would be like I order 1,000 units, and then they run another 500 at night and sell those in the gray market. And to protect against that, since everything we do for the most part is electrical, software, and mechanical, the only one that you can really protect is software. What I'll do is I'll consign my processor to often the ABNet, which is based in Hong Kong, not in China. Everybody's scanned in, there's no pockets, no cell phones, none of this. The bootloader, which is in a special part of, protected part of memory, like the encryption engine, is programmed in, and then I consign my 1,000 processors to the factory. So I know they can't build more than 1,000. And I know my scrap rate is like 0.5%, so I should, if I cared enough, I could get those few broken chips back to confirm. And then because it's got a bootloader, I can just send over the encrypted code, and they can squirt it in, and I know I'm fine. The challenge is, and John was getting at this, if you do split up, like with Apple often, or anybody that's super, super big and paranoid, they might have 5 different factories building it and then send it over to the US to put it together, which is awesome. But the problem is you have to coordinate 5 different factories, and just logistically, like suppose you've got 2 mating parts that are in different factories, and you change the whole pattern in one, you've got to line that up. And it's going to be more of a nightmare. That if you just pick factories you trust, you're good. And then if you think of it also, you've got the bosses, the engineers, and the workers. The workers, the worst they can do is give your competitor a product you're already building, but your competitor can just go and buy it. The bosses will never, at a good factory, will never screw you because they would lose all their business, and they're just taking money out of their own pocket. So you have to worry about the mid-level manager. And he or she is probably making like $400 a month. And cultures in China, it's just somewhat different. So there's a situation where somebody might offer them $1,000 for a DVD, and it would be okay to give that. Not so much for you, but it's just a different way of looking at the world. So you want to protect against that. And because of that, you'll have often a IP controlled booth. You always want to do good IP hygiene. And then we like to have feet on the ground at all times, so that you always have eyes kind of looking around.
When you say feet on the ground, these 10 people that are overseas, is their job to walk around the factories or things that are in
Yeah, some of them. Yeah, our project managers are physically like, say for Pebble, we've got 2 guys, one in each factory. They're just part of the Pebble. They're driving, but they're part of the Pebble team, like on the ground. They speak the native language, eyes and ears. Because the analogy I like to use is I went to your house for dinner. Because I haven't been there, I grabbed the doorknob, and it's probably where most doorknobs are, and feel great. When you go home, if somebody magically moved the doorknob down ½ an inch, you would know instantly that something's not right. Like you wouldn't know maybe what it is, like your radar, your antenna would go up. And it's the same thing, like in China, things drift like crazy. There's a 20% year-on-year worker turnover, especially near CNY. So what you will often see is, new workstations will come in. The fixtures will change out. There'll be a different process. And if you're not walking up and down watching that, you'll find out, but it's probably going to be 3 months later. It's nicer to get on higher up.
Cool. Did anybody bring any prototypes of stuff that they're working on that they want to share and show? Chase, you want to show off what you got?
Sure. I want to see it. Yeah. So, as Scott and Shaun mentioned, I'm launching a crowdfunding campaign with Dragon tomorrow, actually. And the product, it's called the Fiesta 5. And it's a device that you wear on your hand, so when you give someone a high five, confetti shoots out. And it's pretty simple and straightforward, but there's like millions of high fives going on every day. So this is our one and only prototype right now, and so we'll see what happens.
Before you move on, I'm very
excited. Do you guys have any
questions?
questions?
Since you're doing such a low scale, you only have one prototype. How did you go about to create that prototype?
Well, we made probably 30 prototypes to get to this one, just through the testing process. It's been 2.5 years. It's just been kind of slow and steady, like something on the side. I found an engineer online through Elance, and it's just been, I've just been learning, from day one. I ended up bringing my engineer in on the project because I just couldn't pay him anymore. And, it kind of became his baby too, and he just loved the idea. So that helped a lot. But it's really just, they've all been, 3D printed. We painted this one, and just plastic injection, like it was too expensive for us. And one of the biggest problems with this was the 3D printing was just so brittle that it couldn't really withstand the mechanical force of the spring that we had in there. So we just kept breaking these things and going back to the drawing board and making it a little bigger. And we wanted it as small as possible, but it seemed like most of you guys have that engineering background, so maybe you wouldn't have made that mistake. But
I'm a musician, I have no idea what
I still break all my stuff on the 3D printer.
Glad I'm not the only one, but yeah, we can show it off if Bolt doesn't mind confetti going everywhere.
Go for it.
So you want to?
Yeah, let's high five.
Be the guest?
Wait, there has to be a reason for the high five.
I see the Kickstarter.
Well, we go live tomorrow.
Yeah, congrats. Nicely done.
So it's reloadable. We'd like to use biodegradable confetti, but it doesn't, have that shimmer. See, all the confetti actually didn't even come out. I was a little nervous, so I packed a lot of confetti in these. But oh yeah, one problem that we had actually just changed like past couple days is we wanted this to be totally customizable, like so you could customize it to your sports teams or something like that, or an event. But I think the biggest thing that I learned through this crowdfunding was just to remove everything that you possibly can that costs money. And like the point of the crowdfunding is to get like 5, 10, 100 units out. Just like make some units, reach your goal. And then after we reach the first goal, hopefully we can strive for another goal that can let us customize further, or maybe even explore China. But
Awesome.
yeah, thanks guys. So it's called the Fiesta 5, and you'll see it dragging them up.
Yeah. Should fund it. Did anyone bring anything? Any other prototypes? People brought like 10 prototypes last time. We all chatted.
I didn't know we were supposed to bring more.
Don't worry about it. Okay. Cool. Well then, thanks everyone for coming. I'm sure there's still pizza and drinks and beer and stuff. Feel free to hang out for a bit and chat with us. And yeah, otherwise we'll see you next time.
Awesome.